Hey guys, today we are going to go ahead and look at our fourth and final conic section, the hyperbola. Now today is a notes only day. What that means is all you are required to do for pre-calc is go through the notes with me, learn a little bit about the hyperbola, but there is no assignment for today. So what that means is if you're behind on anything for pre-calc, please do the notes with me and then go ahead and work on some of those missing assignments, because Friday, as long as you're caught up, you guys, you get to be done on Friday. Okay, so again, today, no assignment, just work on anything that maybe you are a little bit behind on. Without further ado, let's go ahead and look at the hyperbola. The hyperbola is a conic section. The points are coplanar. And what that means is that all of the points have to be in the same plane. Okay, so a whole geometry thing again. This time, we are looking at a difference. So when we had the standard equation of the ellipse, it was two fractions with a plus sign in between and it equals 1. When it is a hyperbola, it's going to be a minus sign. So if you go ahead and look at those equations, very similar to the ellipse. In fact, so similar on your notes, I had a typo. This is the standard equation for a hyperbola. An ellipse must be a plus. A hyperbola must be a minus. Now here is the difference. With the ellipse, the biggest denominator was A and the smallest denominator was B, okay? In this case with the hyperbola, 100% of the time, A squared is first. It does not matter if it's the biggest or the smallest. A squared is first, B squared is second. Again, it's always a minus and it's always equal to 1. Now, in order to see if it's horizontal or vertical, you just look at the first fraction to see which variable you have. So if the first fraction is an x, it's horizontal. If the first fraction is a y, it's vertical. So in a way, I kind of think the hyperbola is maybe even a little bit easier because it's all just based off of where is it located in the equation. Again, just like with the circle and the parabola and the ellipse, the center is at HK. So what are you subtracting from the x? Whether the x is first or second, that's the x value for the center. What are you subtracting from the y? That's the y value for the center. Now A is the square root of the first denominator. That's what A is. B is the square root of the second denominator. Again, A is how you get from the center to your vertices. That's that distance. B is how do you get from the center to your co-vertices. Here, you're gonna make what's called a fundamental rectangle. You guys, this is so fun. I'm excited to show you this. Okay, so you're gonna go ahead and make a fundamental rectangle. That allows us to create asymptotes. Again, just like with the other, the last couple conic sections, we do have focus points. That distance from the center is C. This time, again, a little bit different than the ellipse. It's c squared equals a squared plus b squared. Now with the ellipse, it was a squared minus b squared. So the difference between the two, graphically, they're going to look very different. Equations, you just change a sign here and you just change a sign here and you can go from an ellipse to a hyperbola. Kind of cool. Okay, so if you are looking at a horizontal hyperbola, what that means, we are going to have what's called a fundamental rectangle. Okay, and it doesn't matter if your rectangle is more wide than tall, it really doesn't matter. What's going to happen is, again, you'll graph your vertices. So let's say this is horizontal, just so you get kind of a basic shape. If this is horizontal, that means your vertices are going to be side to side. Your co-vertices are going to be up and down. So this time I made my center at 0, 0. Okay, so what happens is you graph your vertices and your co-vertices. That's how you make that rectangle. Then you create what are called asymptotes. And remember in class, we talked about that line that's kind of like lava. You want to get really close to it, but you can't touch it because it's hot. That's what these asymptotes are. Now, next to your vertices, okay, on the outside of the rectangle, that's where your foci or your focus points are going to fall. And your focus points are always in what are called the branches. So remember, a hyperbola, it has two U-shaped pieces. This is horizontal. That's why they're opening side to side. The focus points always have to be inside of the branches. Now, if we have a vertical, I can't spell and talk at the same time, you guys. If we have a vertical hyperbola, that means the vertices, let's say the center's at 0, 0 again, the vertices are going to be vertical, so up and down. Your co-vertices are going to be side to side. From your vertices and your co-vertices, you make what's called the fundamental rectangle. Now your asymptotes have to cut through the corners in the center, corner in the center. And what this is doing is it shows you how wide the branches are going to be. Now again, if this is vertical, your foci points are next to the vertices, but on the outside of the rectangle. That way, when you make your branches, you have to make sure the focus point is inside the branches. You use your asymptotes to see how wide this should be. So here would be my focus point. There would be the asymptotes. Okay, so this is just the general shape, our general information. If you understood the ellipse, very, very similar. So let's go ahead and go through some examples today, and then I will let you go about your day. So if I am looking, this is in the correct format because there's two fractions, minus in between, it's equal to 1. The first fraction, the variable is a y, so this is vertical. A, the A value is the square root of the first denominator. That's 4. B is the square root of the second denominator. So that's a 2. Now C squared is A squared plus B squared. So C squared equals A squared is 16 plus B squared. 2 squared is 4. So C squared equals 20. You have to take the square root because you want to know what C is, not C squared. If I take the square root of 20 and round it to the 10th, it's 4.5. So I know this thing is vertical. I know A is 4, B is 2, C is 4.5. The center, where is the middle of all of this? What are you subtracting from X in parentheses? Nothing. What are you subtracting from Y in parentheses? Nothing. So you're centered at 0, 0. Now your vertices, because it's vertical, we are going to change the Y value. Your vertices are always the A. So I have to take A and add it and subtract it to the Y value from the center. 0 plus 4 is 4. 0 minus 4 is negative 4. So my vertices up 1, 2, 3, 4. And down 1, 2, 3, 4. There are your vertices. Your co-vertices, because the vertices are Y, that means the co-vertices are X. Your co-vertices always go with the B value. So I'm going to take the X value from the center and add and subtract B. So 0 plus 2 is 2, you leave the Y the same. 0 minus 2 is negative 2, leave the Y the same. So I go to the right 2, go to the left 2. Once you have your vertices and your co-vertices, go ahead and make your fundamental rectangle. So just like a dotted rectangle. Now from there, you go from corner to corner through the center and extend it. Those are your asymptotes. Those are the hot lava lines. Now what we need to do is get the foci. Now the foci points, I always go with the vertices. The vertices, we change the Y. So the foci, we also change the Y. And again, you go back to that center. So I'm looking at 4.5. 0 plus 4.5 is 4.5. 0 minus 4.5 is negative 4.5. So if I go up 4.5, yep, it's higher than the vertice. If I stay at 0 and I go down 4.5, yep, it's lower than the vertice. You always draw the branches so that way they get close to the asymptotes but don't touch, and make sure the focus point is inside. And that's it, you guys. Kind of cool. I like this one the best. I just kind of think it's pretty and it's fun to graph. Let's look at the next one. The next one has a what if scenario. What if it's not equal to 1? Because the rule is it has to be equal to 1. Well, if it's not equal to 1, you have to make it equal to 1, you guys. So go ahead and divide everything by 100, because now 100 divided by 100, that's a 1. 4 over 100 is 1 over 25, so it's x squared over 25. Minus sign. 25 over 100 can be reduced to 1/4, so it's y squared over 4. So here is the correct equation. If it's not equal to 1, you have to make it equal to 1. Now if I look, cool thing with this, it's the first fraction. The first fraction has an x, so that means this is going to be a horizontal hyperbola. That means that the branches are going to open left or right. Like this was vertical, so they open up or down, the vertical direction. This next one, we're going to have one to the right and one to the left. The a value is the square root of the first denominator. The square root of 25 is 5. B, the square root of the second denominator. The square root of 4 is 2. C squared equals a squared plus b squared. So c squared equals 5 squared is 25. 2 squared is 4. So c squared equals 29. Take the square root of that, and c equals, if I round it to the 10th, 5.4. Okay, so let's go ahead and graph this thing. Center, what are you subtracting from x? Nothing. What are you subtracting from y? Nothing. So it's 0, 0. Your vertices. My vertices go with what kind of hyperbola it's going to be. It's horizontal, so I am changing the x. Vertices is always with the a value. So if I take 0 plus 5, it's 5. You keep the y. 0 minus 5, it's negative 5. You keep the y. So I go to the right, 1, 2, 3, 4, 5, dot. Go to the left, 1, 2, 3, 4, 5, dot. Okay, co-vertices. Because I changed the x for the vertices, that means I changed the y for the co-vertices. Co-vertices are always the b value. So I take the center, and I'm going to add and subtract 2, because that's the b value, to the y. So I keep the 0 the same. 0 plus 2 is 2. Keep the x the same. 0 minus 2 is negative 2. So I go 0 up 2, 0 minus 2, and you go ahead and make your fundamental rectangle. Okay, now I gotta make the asymptote. So I'm gonna go ahead and go through the corner of my fundamental rectangle, go through the center of the hyperbola, and look at how cool that is. Okay, now what I need to do though is I need to find those foci points. And the foci points have to go with the vertices. So if the vertices were x, your foci points have to go with the x. So I'm taking the center and I'm using the c value and I'm adding and subtracting it to x. So 0 plus 5.4 is 5.4. Keep the y the same. 0 minus 5.4 is negative 5.4. You keep the y the same. Now, when you graph these, they should be next to the vertices, but outside of the rectangle. So I go to the right, 5.4. Yep, it's on the outside. Now I can go ahead and make the branch because you hug the focus. That's what I would have said in class if we were together. I'd have been like, hug your foci. Okay, go ahead and hug it. It always has to be inside of the branches. Okay, now if I go to the left, 5 and a little bit, there's your focus point. And you give it a great big virtual hug because with COVID-19, we can't give it a real hug. Haha. Okay, let's go ahead. Look at the backside. I hope you guys are having fun. I love the hyperbola. This stuff is so fun. Okay, next one. It is in the correct format. I have 2 fractions. I have a minus in between. It's equal to 1. Good to go. First fraction has a y, so that means it's vertical. It's always off of the first fraction. Now, a is the square root of the first denominator. That's 2. B is the square root of the second denominator. That's a 3. C squared equals a squared plus b squared. So c squared equals a squared is 4, b squared is 9. So c squared equals 13, but I want to know c. So c, I have to go ahead and take the square root of 13, and if I were to round that to the 10th, I get 3.6. So it's kind of nice because right now I already know it's vertical. I know the a, the b, and the c. Now, let's go ahead and start this. The center, what are you subtracting from x? It does not have to be, x does not have to be first, but you do have to use the x to find the x value for the center. So what am I subtracting from the x? A 2. What am I, that sounded like a sneeze, a 2. Okay, sorry. What am I subtracting from the y? A negative 3. So if I go to the right 2, go down 1, 2, 3, there is the middle where this is all going down, guys. All right, vertices. Now vertices, I always go with what kind of hyperbola it is. It's vertical, so we are going to be changing the y. Vertices is always the a value, so I'm keeping the x the same. I take the y, -3, and I add a. -3 plus 2 is -1. Now for the next one, I'll keep x the same, take the y value from the center and minus a. -3 minus 2 is -5. So I go to the right 2, down 1. Go to the right 2, down 1, 2, 3, 4, 5. Those are my vertices. Your co-vertices, because my vertices I changed a y, my co-vertices I change an x. Co-vertices, you always use the b value. So again, you're using your center. So I'm keeping the y, the -3, that doesn't change. I'm changing the x, and I'm adding and subtracting 3. So 2 plus 3 is 5. 2 minus 3 is -1. So those are my co-vertices. I go to the right 1, 2, 3, 4, 5, down 1, 2, 3, co-vertice. Go to the left 1, go down 1, 2, 3, co-vertice. Once you have those 4 points, fundamental rectangle time. Now make your asymptotes. Lots of fun dotted lines. You can do different colors. Oh yeah, good stuff right here. Okay, so this is what I have so far. Now you need to find your focus or your foci, focus points. Okay, now your focus points, I always go with the vertices. My vertices, I change the y, so the focus points, you also change the y. And again, you always use the center. Focus points is 3.6. So I keep the x 2 for both of them. Now if I take -3 plus 3.6, I get 0.6. If I take -3 minus 3.6, I get -6.6. So those are the foci points. So I'm going to go ahead and go to the right 1, 2, and up 0.6. Hug the focus. This is just a wide hyperbola. Go to the right 2, down 1, 2, 3, 4, 5, 6, and even a little bit more. Hug the focus. And it's vertical. Your branches should open up or down. It does. You're good to go. All right, the next one, it's another what if. Well, what if it doesn't equal 1? You have to make it equal 1, you guys. Divide by 9, divide by 9, divide by 9. Here's your new equation. So it's x plus 4 quantity squared over 9 minus 9 cancels 9. So y minus 3 squared over 1 equals 1. That is your equation. Now, if you want to know if it is horizontal or vertical, you have to go ahead and look at the first value. The first variable from that first fraction is an x. So that means it's going to be horizontal. If it's horizontal, that just means that your branches open side to side. A, the square root of the first fraction, 3. B, the square root of the second fraction, 1. C squared equals A squared plus B squared. C squared equals 9 plus 1. So C squared equals 10. Take the square root. C equals, if you take the square root of 10 and you round it to the 10th, you would have 3.2. So I know it's horizontal. I have my A value to find my vertices, the B value to find the co-vertices, the C value to find the foci. So let's go ahead and do this. The center, what are you subtracting from x? -4. What are you subtracting from y? 3. So I go to the left, 1, 2, 3, 4, and up, 1, 2, 3. That is the center. Your vertices, because it's horizontal, you are changing the x using the a value. So for my vertices, the y value stays. I take the x value from the center and I add 3. -4 plus 3 is -1. Now you minus 3. -4 minus 3 is -7. So -1 up 1, 2, 3. There's a vertice. Go to the left 1, 2, 3, 4, 5, 6, 7 up 1, 2, 3. There's a vertice. Now I need co-vertices. If I used x for my vertices, then my co-vertices I have to change y. So that means the x is going to stay -4. Okay. What I do for co-vertices is you use the b value. So I take the y and I add 1 because that's what the value of b is. 3 plus 1 is 4. 3 minus 1 is 2. So I go to the left, 1, 2, 3, 4, up, 1, 2, 3, 4. Oh, this is gonna be a small rectangle, guys. Go to the left, 1, 2, 3, 4, up, 1, 2. Once you have your vertices, your co-vertices, and your center graphed like we do, make your fundamental rectangle. That helps you to form the asymptotes. Have fun with this. It's like a little art project during pre-calc time. Okay, now last but not least, you need your foci points. The foci points need to go with the vertices, so again, I'm changing the x. When you find the foci points, you're using your C value, which is 3.2. So I'm keeping the y the same, okay, from the center. I'm changing the x. -4 plus 3.2 is -0.8. -4 minus 3.2 is -7.2. Those are your two foci points. So I go to the left almost a whole unit, go up 1, 2, 3. There's the foci point. It's on the outside of the rectangle. Hug the focus. Go to the left. 1, 2, 3, 4, 5, 6, 7.2. Go up 1, 2, 3. It's outside of the rectangle. Hug the focus. This is horizontal. That's why the branches open side to side. Mrs. Becker, what happens if it's not in standard form? Well, again, this is the general form for the equation for the hyperbola. If they ever give you the general formula, you have to complete the square, just like we did with the parabola and the ellipse. So hopefully the skill has come back to you and it's pretty comfortable again. I want to group the x's together. 2x squared plus 4x plus, we have to find the magic number. Plus, now you group the y values. -y squared plus 4y plus, we don't know yet. This -4 does not have a value, or it does not have a variable, sorry. -4 does not have a variable, that's why I had to move it to the other side. You cannot complete the square unless your leading coefficient is a 1. So in the first group, I need to divide a 2 out of both of those terms, leaving me with x squared plus 2x plus, we don't know yet. Same thing here. You cannot complete the square unless this is a positive 1. In order to get rid of a -1, I need to take out a -1. But you have to divide that out of everything that's in the parentheses. So the signs for both of those terms would change. Now it's time to complete the square. You take b, the number in front of the single variable, divide it by 2, then square it. So 2 divided by 2 is 1. 1 squared is 1. But this 2 goes to everything in this set of parentheses. So even though I added a 1 here, this actually has a value of 2 because 2 times 1 is 2. So I need to add 2 to the other side because what you do to one side of an equation, you always do to the other. Now I complete the square here. -4 divided by 2 is -2. -2 squared is 4, but this is really -1 times 4. So this is really a -4. What I put on one side, I have to put on the other. So I have to minus 4. +4, -4 cancels. Now I can complete the square. So it's 2. Two numbers that are the same, that multiply to 1 and add to 2, well, that's 1 and 1. Minus, now this is a 1, so I don't have to show it. Two numbers that are the same, that multiply to +4 and add to a -4, that's -2 and -2. Equals +4, -4 cancels, you get a 2. Okay, so it's getting closer. We're not ready yet because this has to equal a 1. So I need to divide everything by 2. Here is the equation. X plus 1 quantity squared over 1 minus y minus 2 quantity squared over 2 equals 1. This is the standard form of an equation. So again, it's an important skill to be able to go from the general form to the standard form. The first variable in the problem is in x, so it's horizontal. That means that the branches are going to open right and left. A, the square root of the first denominator, 1. B, the square root of the second denominator. Well, the square root of 2 is 1.4. C squared equals A squared plus B squared, so C squared equals 3. Take the square root of 3. The square root of 3 to the 10th is 1.7. So I know it's horizontal because the first variable is x. The square root of 1 is 1. The square root of 2 is 1.4. When I use the formula, c squared ends up equaling 3. So if I take the square root of each side, c has a value of 1.7. Now I can go ahead and start graphing. The center, what are you subtracting from x? -1. What are you subtracting from y? 2. So I go left 1, up 2. That is the center of all of this. Your vertices. Because it's horizontal, you are changing the x. And I'm changing the x by adding and subtracting a, which is 1. So -1 plus 1 is 0. Keep the 2 the same. -1 minus 1 is -2. You keep the y value the same. So I have 0 up 2, -2 up 2. Co-vertices. I have to change the y. So I'm keeping the x -1. Now what I have to do is add and subtract 1.4 from the y value. So 2 plus 1.4 is 3.4. 2 minus 1.4 is 0.6. So I go to the left one, up 1, 2, 3, and a little bit. Go to the left one and up a little bit more than half. Make your fundamental rectangle. Create your asymptotes. And now we need to find the foci points. I'm going to go right up here. I'm running out of room. Your foci points have to go with the vertices, so we're changing the x. That means the y value from the center is going to stay a2. What I'm adding and subtracting to find the foci points is 1.7. So -1 plus 1.7 is 0.7. -1 minus 1.7 is -2.7. So I go to the right a little bit more than a half and up 2. There's the focus point, hug the foci. I go to the left, 1, 2, and almost 3, up 2. It is not in the rectangle. The branches hug the foci. Okay, the last thing that we're going to go ahead and look at is if you're given information, can you figure out what the equation would be? And that's all you have to do. You don't have to graph it. It's just find the equation. So the center is 0, 0. So I'm going to have just an x squared and a y squared, but we have to be able to figure out which one comes first. Remember your vertices, that always goes with the first fraction. So in this case, if my center was 0, 0, in order to get to 0, they added 2 to the x. That means it's horizontal. So it's x squared minus y squared equals 1. Now, a is what you add and subtract to get your vertices. The bottom of the fraction is a squared. So you would take 2 squared, and that's a 4. Now this is c. Okay, so a is 2, c is 3, because you add and subtract it. I need b squared. The formula is c squared equals a squared plus b squared. Well, if c is 3 or even -3, if you square it, it's 9. A is a 2. 2 squared is 4 plus b squared. So if I minus 4 to each side, 9 minus 4 is 5. So b squared equals 5. This is a squared, this is b squared, so it's 5, and you're done. You just have to make the equation. Okay, here's another one. Again, your center is 0, 0. So when you have your x's and your y's, they will not be adding or subtracting anything in parentheses. Your co-vertices, that's your b value. Your vertices, that's your a value. Now the vertices changed the y. That means that this is a vertical hyperbola, so y squared comes first. If it's horizontal, the x comes first. If it's vertical, the y comes first. Now the denominator, the bottom of the first fraction is a squared. A would have a value of 5 because I had to go from 0 to 5. So what did you add? You added 5. So 5 squared is 25. B, they took 0 and they minus 3. So b would have a value of 3. In the formula, it's squared. 3 squared is 9. There is your equation. Guys, that is everything that you would possibly need to know for the hyperbola. I hope you enjoyed our time together. Again, no assignment for the day. Have a great one.